Hello everybody, welcome to Dr.K.Liu Maths channel. This question is from a year 2 student who asked me how to do this probability question distribution. It should be belong to bivariate random variable, bivariate, because there's two random variable x, y. Okay, then there is a basic concept for a function given that there is the a random variable or two variable. It has a properties of that each xy should be between 0 and 1. Of course, you can put each pair of xy, you will observe that properties. On the other hand, because it is continuous, therefore you can do the integration. It is a double integration fx y. And I think I'm here try to do the dy first and then dx. And then the range of y should be x 0 to x squared. Y's value should be x 0 to x squared. The value of x should be -1 to 1. That you can check this is 1. And if you change the position, you have to take care the domain here. But anyway, it is the definition of bivariate random variable. Okay, in order to find the marginal function of fx, you have to integrate fxy of dy. That is why I have to do the position should be of dy first, the integration of dy first. And this is 0 and x squared, because that the question give you the domain of y. Okay, put that 0 x squared, then 2 over 5 x squared dy. This is equal to 2 over 5 x squared y. Put the 0, put the domain into that we have. Okay, let me check. Okay, and that answer is 5 over 2x to the power 4. Of course, we have matched the domain here. That is for x, the x value is -1 to 1. Otherwise, it is 0. Okay, I think it is a harsh problem is for this one, because if you try to find the marginal function of y, you have to integrate this function. With respect to x. Okay, but you can see that the domain here, the y, because this is function of y, this is function of y. Therefore, you have to change the domain here. Then you solve this inequality. You can get x is greater than or equal to root y, or x is less than -root y. Insert x between -1 and 1. Combine this one, combine this condition and this condition. We have actually the range of x is -1 and -root y, or root y to to 1. Therefore, I write down this is domain. The domain here should be decomposed into two parts. One part is -1 to -root y. The other part is root y to 1. Otherwise, you cannot get the right answer. Therefore, it actually concerned with the theorem of multivariable calculus. Of course, if you have problem, you can relate it to that topic. And I also have many full looks of the multiple variable calculus. And on the other hand, this part and is about the probability of bivariate random variable. I also finished my presentation in the YouTube channel. If you are interested, you can join our membership so that you can get the right video. If moreover, if you want to get looks, you can contact me, and we actually have the looks selling looks for you. Okay, now for this one, 6, 5 x cubed -1 negative root y plus root y 1. Oh, sorry. 5 over 6 x cubed root y 1. Then you can calculate it is easily. And this is 5 over 3 minus 5 over 3 y to the power 2 over 3 over 3. You have to write down the domain of y. In this case, the domain of y should be 0 and 1. Because you can see that y is 0 to x squared. X squared must be the maximum of x squared is equal to 1. Because it's the condition. Therefore, it is domain. And of course, you can write down if that 0 otherwise. Okay. Okay, next for the EX and C. EX, you can directly calculate the value of expected function by using the marginal function of x. Therefore, by definition, that is fx x dx. The domain is this one, -1 to 1. -1 to 1 x, the fx is, let me see, 5 over 2 x to the power 4, yes, dx. Then you can integrate this function easily over 2, then that is 6 x to the power 6, -1 to 1. And you can get easily that the result is 0. That is so pity. Okay, for part C, part D. Part D is found a conditional probability f given y. You have to notice that the conditional function f given y, fx given y, this is actually a function of x. Function of x. Therefore, you have to mention after you do the integration, by definition, that is fxy over the marginal function of y. That is by definition. Then, but you have to mention, because it is the function of x. You have to mention the domain of x. What is the domain of x? That is a critical point and also very important. And for fxy, it is 5 over 2 x to the power 2. And for the marginal function of fx is this one. Yeah, this one. You actually, you only need to put that into the function. Okay, I here try to simplify. The 5 is cancelled. The 1 over 3, then 3 over 2 x squared, 1 minus y, 3 over 2. And for the domain of x, because you have to mention the domain of x. The domain of x should be not this one, but it is this one. Because we can see that for integration of that function, we have changed the domain of x here. Therefore, it is very, very important here. Otherwise, the solution is not true. Okay, for E, the final part, the continual function of f y given x. It is a function of y. Therefore, you have to mention the domain of y. The domain of y it is easy. Not this one, but this one. Not this one, because it is marginal function. The overall should be here, the domain. Okay, by definition, it is the Bivariate joint PDF over the marginal function of x. Marginal function of x is 5 over 2 x to the power 4, and the joint PDF is 5 over 2 x to the power 2. That is 1 over x squared. Then for the domain of y should be 0 and x to x squared. That is the answer of this part. Okay, I hope guys can enjoy this video, and I hope I can solve your problem. How to deal with this kind of function. And if you are interested in my logs, you can contact me. And if you only interested in the video, you can join our membership. You can see that the course is probability 1. Probability 1 will contain all those materials, very user-friendly, and also in Chinese language, in Cantonese. Okay, I hope you really helped you to solve your problem. Okay,